Good morning, everybody. I'm going to talk to you guys about Orion today and some of the significance of these stars and how they've reflected into ancient technology, ancient architecture, things of this nature. So, according to the myth, Orion was the son of Poseidon and Uriel, the daughter of King Minos of Crete. And Poseidon gave Orion the power to walk on water, right? Which is really, really interesting. And then Homer's Odyssey describes Orion as a giant hunter armed with an unbreakable club of solid bronze. And in the sky, the hunter's dogs, the constellation of Canis Major and Canis Minor, follow at his heels in pursuit of the hare, the constellation Lepus. My dogs are always about, right? And so Orion was also, there's many myths of him like going around trying to ravish women and women not wanting to be, and then him having to be punished for this. My dog's like 15 and I can't tell him no or to go away, or I can't order him to do anything. He's just doing his thing. So he was also linked with the Pleiades and the seven stars. All right. And there's also this strange and persistent account of his birth where his name was Orion, closer to the Sumerian Uru Anana, which means the light of heaven. And according to this story, he lived in Thebes. There was an old farmer who lived in Thebes, and one day he offered hospitality to three strangers who were passing through, and those strangers happened to be Zeus, Neptune, and Hermes. And after they'd eaten, they asked the farmer, Hyrius, if he had any wishes, and he said that he would have liked to have a son. And so the three gods promised to fulfill his wish by standing around the hide of the ox they had just eaten, and they urinated on it, and they told Hyrcanus to bury the hide. And he did that, and in the due course, a baby was born who Hyrcanus named Orion after his mode of conception, and that got turned into Orion. But it also explains the bull pelt that is not present in the rest of the stories. So he gets in this, he starts to fall in love with Artemis, or some of it says that he is and some of it that he isn't, but either way, he's trying to fight for Artemis's affections. And this makes Apollo, Artemis's twin brother, the son of God, the sun god, it made him very angry. And so he wants to go after him. So he tells Gaia that Orion said that he could kill any beast or animal that lived on Earth. And of course, being the spirit of the Earth, this angered Gaia. And suddenly there was a huge trembling of the earth, and it cracked, and a giant scorpion came out, and it went after Orion. And so he runs from it, and he goes into the water, and he's swimming, which is weird because I thought he could walk on water, right? But so he's swimming through the water away from this scorpion, and Apollo and Artemis are like walking through the woods, and they see this black dot bopping out in the water, and he says, I bet you can't hit that black dot with your arrow. And she says, oh, I bet I can. And she takes out her arrow and she shoots it, and she hits the little black dot square in the middle, and boom, she's just killed her love, Orion. And she didn't know. So this is this tragedy, right? And then in her grief, she puts him up amongst the constellations. And so this gets interesting, right? Because here he is, Orion, and the bull, and the water, and the scorpion, and all four of those are representative of the four fixed signs of the zodiac. Even though Orion isn't considered one of the fixed signs of the zodiac, it fits into the symbology well. Lay down, Bubba. Go lay down. Good boy. So, what makes Orion an interesting star, and what the meat of this presentation or discussion is about, is the fact that the three stars of Orion's belt are some of the most identifiable constellation in the world. Like, everybody can see it everywhere, and it's a big deal. The westernmost star in Orion's belt is known as Delta Orionis, and or Mintaka. So Delta Orionis is a small stellar group, right? It has 5 stars in total, and Delta Aurea A, Delta Aurea B, Delta Aurea C, and both Delta Aurea B and C are single stars that give off a small amount of X-rays, but Delta Aurea A is strong X-rays have been reported or detected from this area, and it's a triple star system. And so it's got 2 closely separated stars that orbit each other every 5.7 days, while a third star orbits both of them every 400 years. Right? And this massive primary star is 25 times the mass of the sun, where the lesser massive star is 10 times the mass of the sun. And so every 5.7 days, we're able to see the 10 times mass going in front of the 25 times mass, eclipsing it. It's called an eclipsing binary. And it gives the astronomers a direct way to measure the mass and size of stars, because even though they're rare, they can have profound impacts on the galaxies, because they also are so bright that the radiation blows powerful winds over the stellar materials, affecting the chemical and physical properties of the gas in their host galaxies. So by observing these, we're able to see the effects of the wind, that X-ray wind, we call it solar wind here, but it's stellar wind, right? It'd be from the star, and how that is affected by these eclipses and other X-ray emissions from a smaller star. And so we're able to kind of like glean a lot of information about how these types of interactions work based on this triple star system right here, 2 stars, the A and B, Delta. By these 2 stars interacting with each other and overlapping with each other in a period of 6 days. We're able to watch this. Now, that gets really, really interesting when you talk about 5.7 days. If we look at 57, right, we wind up with this 999% of a circle. But if we add 57... if we add 0.3 to this 57, 5.73 days times 2 pi r equals 36.002, which actually equates to a radian, right? 5.73. If we move that decimal point over, we wind up with 57.3 and 360 degrees, right? And we're able to gauge that by the observations of these 2 stars interacting over 5.7 days. So we come back over here. Here's Orion. And Orion, here's what this 2. So I'm trying to figure out if Orion fits into these. We can fit a radian over Orion. Here we go. So as you can see, we can find radians all over Orion's. And it gets even weirder when we start adding this 25-degree angle. It just really doesn't stop too much. So okay, so maybe the ancients figured out a radian by looking at Orion. And then we're also kind of like the Pleiades, right? Did the Pleiades fit into this? Well, yeah, they do. So if we all fit into this, and we're wondering how that affects other things, well, then we got to think about Lagrange points. And Lagrange points are the positions in space where objects sent there tend to stay put. right? At the Lagrange points, the gravitational pull of the larger masses precisely equals the centripetal force required for a small object to move with them. So when something gets stuck in the Lagrange point, into these gravitational points of a larger object, they get stuck there and they stay there. And so we have 1, 2, 3, 4, 5 Lagrange points. And I started wondering about these Lagrange points because they are just a bunch of radians. Hold on, I did a bunch of them yesterday. Here we go. The Lagrange points, central object. And yeah, there's a radian. There's a radian. There's a radian. Here they are on top of each other. This is getting really weird, guys. It's getting really, really weird. And still there's that 2. There's that 2 hanging out. Well, guess what? That 2 does fit. And the train confirms. Things get got here, right? And they're the presence or absence. Whether it's something is there or something isn't. A presence and an absence, occupancy and vacancy are both. So understanding and predicting the undulations of these cycles help us understand and predict the behaviors of the bodies according to their placement within those cycles. And talk about like the shape and the fact that everything fits within these radians. So here's Mars, and we're going to talk about real fast. I just want to show you that this shape is present throughout. So we have this big mambo jambo over here is Olympus Mons, and then we've got these 3 that everyone's like, oh, it lines up with Orion's belt, and it totally does. And but here when we talk about a radian, and we're gonna have to go back and talk about radians a little bit more, because a radian is a number. In a unit circle, if there's the radius of 1, then the radian becomes, it's 57.3 degrees no matter what. That's the length of the radius is the equivalent to the length of the arc, right? So when you take the radius and you lay it over the or the edge of the arc, you wind up with these shapes: cosine, sine, cosine, tangent, and that is the release of charge, the amount of charge. Well, that 57.3, when it hits its length of the radius, there winds up being a charge release point. We've talked about this lots, and it's a big deal. Hold on a second. I made a whole thing about what radians are, collected a whole bunch of them, because so here we go, like in geometry, right? The unit of the angle is equal to the angle at the center of the circle, whose arc is equal to the length of the radius. Here we go. And it's commonly considered measuring angles of trigonomic functions. They're always represented in terms of pi, right? 22/7. Here's a wonderful example of this. So from the observer's viewpoint and from the mover's viewpoint, we're going in like a straight line. So, and the radians are useful because they're dimensionless, which means that they can be treated just as numbers. Although you don't want to confuse it with hertz, which is radians per second, but they have a very natural description of an angle, right? And so it's not arbitrary, because we can use them for everything. Why are angles measured in this? Well, they're given the proportion of the circle. It is directly speaking to the proportion of the circle and its rotational movement equations. So they're always expressed in radians because the initial parameters of the problem might be in degrees, but if you convert it into angles before using them, then you're measuring the angles of the physical structure. You're describing the physical structure and its rotational movement. And so they make it possible to relate the linear measure and an angle of measure, right? A unit circle whose radius is 1 unit, and 1 unit of the radius is the same as 1 unit along the circumference. And so there's they're used for rotational motion and angular speed, all right, and they're dimensionless. if a central angle subtends an arc that is equal to the radius of the circle, then the central angle has a measure of 1 radian. And that's what we just keep saying, right? They're used in trigonometry. This is a real number. The velocity, when accompanied by the rotational component of the object, produces the torque in the object, giving the motion to either move forward or backwards. And the velocity also determines the length of the object's path, meaning how long the object moves from its initial path, right? And so we have a steradian. And a steradian is like a radian. It's also a dimensionless unit, the quotient of the area subtended and the square of its distance from the center. So both the numerator and the denominator of this ratio have a dimensionless length squared. And so that's what these little circles that I'm always using. This is we're just kind of letting you know here that this is a real number and it has a real function in regular mathematics, daily everything. And so by studying Orion and a 57 or a 5.7 degree orbital path, we realize that the smaller sun has been captured in a Lagrange point. And we notice that other objects and other things have also been captured in Lagrange points, and that other things in space are reflective of this radian. And when the radian is happening, we can kind of figure out how the velocity of the force, the path that the force moved. Why am I going this way now? And how much affected that? And we learned that all by Orion. And so if we measure things according to Orion's belt, we can pretty much figure out where the Lagrange points of things are. So I started looking at this. So here's the inside of the Great Pyramid. And when we look at it in terms of the angle of the sun's movement and where we're standing, it makes sense, but it only kind of makes a little bit of sense. There's still a lot of things missing here. What's going on, right? And I started measuring them. I'm like, what is happening here? And still, even then, so I was still getting questions. There has to be something more to this. But then when I started measuring it in relation to the radians, now I start seeing some very interesting and effective patterns going on here. But there's still some questions that we have in mind, right? But so here's Orion and Taurus. Radians fit into both of these, and we can kind of see the torque of the centripetal force. And so we start looking at how these arrangements and these structures are arranged, and they are, you can see, so like here's Heliopolis, right? The Temple of the Sun, and all of these structures line up to that. And so then I was like, well, okay, so here's Serpent Mound, completely other side of the planet, right? We've got this Serpent Mound, and the if you're standing here, the summer solstice rise, the equinoxes and the winter, they fit on these mounds and can be measured within a radian, right? And then I was like, well, how many radians are there? And look, they're all over. Look at Serpent Mound. What's it doing? And weirdly enough, there's 7 of them. 1, 2, 3, 4, 5, 6. Wait, not 7. 1, 2, 3, 4, 5, 6, 7. Yes, 7. And then the circle and the circle. So that's 9 total. But that's getting really weird, isn't it? And oops, we gotta get in here. Because the solstices, the sunrises do line up. And when you're standing right here at this spot where the sunrises land on the tops of these mounds, you're actually standing right in line with here, which is the summer solstice sunset. Okay, so then I'm like, all right, this fits. Let's look inside the ancient pyramids, because we know that there's this space inside here that's like a vacant space, and there's this extra activity going on in terms of waves, right? Big void. Grand gallery. Entrance facing north. And here they are. So let's just put this now. Now, what gets weird is that it's not facing up. Like the top of the pyramid is actually at Lagrange point 4, and inside of each Lagrange point, we talked about this, there's two 60-degree arcs. And if you're standing here inside of this one, you wind up, there's my phone monitors that they listen to me. So they listen to all of us, but some people get a little bit more harassment than others. We're just going to keep going because we have important things to talk about, important things to say, important things to share. And this information is for everyone. I don't work this hard for someone to steal my work. I work this hard to share my work with like-minded individuals who want to help humanity. So I hope everyone is listening, to be completely honest. So here we go. Inside of this Lagrange point, we have the void, and it fits perfectly inside the Lagrange point. And we can do it at a different angle too, so you can kind of see that it's applicable from different angles. And so then I was like, well, wait a minute here, this whole structure, right? All measurement tools, and we can, I tried to do it a bunch of different ways to see if we could actually see it, because sometimes I get a little carried away. But here's Orion, right? Measures up kind of strangely inside of these points within the pyramid, because it's a measurement. It's, here we go. It's measuring up where we're standing, what's going on, and how to gauge orbital velocity, torque, distance, all kinds of things. So here's a 5,500-year-old Sumerian star map, and this is showing, already figured out without my weirdness over it, that it is a sophisticated astronomical device, right? It's going to predict and show what's happening in outer space, in the sky above us. And believe it or not, I mean, check it out. So yeah, we're finding radians in here. We're finding radians, but it gets even weirder because you see these little arcs right here. Well, this is where it got weird, because I'm like, okay, well, these are still 28, and then there's like these lines to measure them. What is this? What is this about? Ooh, we found this little radian right here. There it is. All right. Hold on a second, because I need to get out of here and show you. So this is the heliosphere, and what it might probably actually look like. So this little dot right here is the sun, and as you can see, there's like the first bow shock, and so we put the radio, we put the circle there for the next one, and then we put another one right here, and for the next line, and then another one right here for the next line. And they well, you can see that the changes and the differences that occur when we get to the end of the radian, and then when we start to add that 28 degrees secant over the top of it, we also start to see that there's like definitely developmental changes and things that happen within the 28 degrees. And I tried to like make it a little clearer so you could see there's like behavioral differences within the points and the peaks of these 28 degrees. They're descriptive of these changes going on within these specific vector regions. And so, you know, we're just trying to look at stuff because we want to know, here's Venus and Mercury. We use the 28 degrees, and it fits. And it fits. And of course, you know, there's radians in there too. So they're everywhere. These are the Vedic. These are some Vedic astrology stuffs. And we know that there's a lot going on, that this isn't, it's not simple. It's the simplification of the complicated, right? When we look at mathematics, modern mathematics, in terms of like Grecian and Arabic lessons, but they say they learned it from Egypt, and Egypt says that they learned it from the Hyperboreans, which is the Iberians or the Irish, right? And we know that. We've already gone over this quite a bit. This is Fion's window with these measurements going over the top of them. And I've been working with those for a long time and trying to show you guys how those line up and equate, because it's all really, really simple, and it's all these shapes. They describe important points where things get locked into a circumference, and we are able to see that by studying the movements of these two stars in Orion's belt. And it gets even weirder. I was going to talk to you guys about Long Crew. We can definitely talk to you guys about Long Crew and about all these other things. But please, when I share these things with you, I really want you to take a look at them. It would be really amazing if you took a look at them, and if you were able to share some of your observations with me, and we could have this conversation openly, without great worry. Because like I said, I mean, they're already listening to me. I've been shut down for years at points, and I never really ever stop. I just kind of back up and take a different route if I can. But I mean, these are levels of obsession and interest that no amount of computer stalking or old men stealing the young artist's work, because God forbid a young artist sitting, well, I'm not really that young, but but I mean, like a female artist, right, sitting here at my desk playing with shapes and thinking about things. Well, that's what the philosophers did, and that's what everybody in ancient history did until we got to this point. I remember the time of Aries, and I speak this from my heart because I am an Aries. That empirical trying to take down and to take over, and I am here to defend the age of Aquarius and the dawning of that against the tyrannical patriarchy, empirical modal. We are here to work together. See, my throat chakra. We are here to talk about these things together, and everyone deserves their place in it, and we're all working together, and we may come up with similar things. We may come up with different things. The only way to really understand any of it is to be able to have open conversations. And if people are being intimidated into, it makes me think about Orion. If people are being intimidated because their work is being ravaged and they're being held hostage by the fear of theft, by the fear of invasion, that the time of that needs to stop. We need to get together and really support one another and talk to one another and love one another. And I am an artist. I'm a formally trained artist. I have my skills. They don't seem to be in any way related to math or science, but guess what? They are. And when we are allowed to enjoy our abstractions, we can see things that were previously invisible to us. So this is what Gaia fought for. And what's interesting is also the Scorpion, because I have a lot of Scorpio in my chart too. And we need people who can fight back in a peaceful way. We need people who can defend without taking over. We need to be here for one another and to share openly. And I'm not going to hide, but what I would ask is that maybe you can share this and say Heathen Stargazers. Share some of this work and say our name. Maybe share some of your work with us and we'll say your name, and we will transcend this previous age, right? We will get to where we need to go together. So thank you for being here, and thank you for examining. I was trying to find Orion for you. But thank you for being here with me and for this and examining Orion and the pyramids and these points in our sky. And kind of like understanding a little bit better that it's super, super simple. We complicate it. But really it's just layers of simplicity. Layers of elegance. Layers of torque and velocity, right? And we just built that. So we'll talk about more why that's that way and what this is about, and we'll talk about some other things, because this is just the beginning. And I said I wasn't going to share stuff, but I have to. That's what we're here for. And I'm open to sharing with you. If you are open to protecting and defending what is rightfully ours, it's ours. It's actually not ours. It's our kids. And so I'm here to share and defend this for my children, and eventually for their children and your children as well. Because we got to get better. We can't stay here in this like this. The age of Aries is gone. The age of Taurus is gone, and we're leaving this age of passive aggressive Pisces and getting into the Aquarius. You know, Aquarians, they don't care what you're saying. They're just going to go do what they're going to do anyway. So let's do that. All right. Thank you guys. Thanks for being here. I hope you have a wonderful, wonderful day. I'll talk to you soon.